Hey everyone, today we are going to go through greatest common factor and least common multiple. Now I shared a video earlier just talking about some basics of factors and multiples, what factors are and what multiples are. Remember, factors are the smaller ones, the numbers that go into other numbers. Then multiples are the ones that are infinite, right? They're the ones that go on forever. Or when you skip count, those are your multiples. Something that's confusing a lot of times for students is just this idea of greatest common factor. So people see this word greatest here and they think that because this is the word greatest, they think that we're going to be dealing with the bigger numbers. And then they see this word least and they think we're going to be dealing with smaller numbers. But typically speaking, the greatest common factor will always be smaller than the least common multiple. Sometimes they're the same, but this one will never be bigger. It's either going to be the same or the greatest common factor is actually going to be smaller. So don't be fooled by those two words. Go through a few examples of these, and there's a couple of different ways you can do each. The first one that we're going to do is a kind of like a real world question. It says there's one slice servings of 3 types of cake. So you got 3 different types of cake. You got marble, red velvet, and chocolate. And there's slices of these on a table, okay? And so you got 10 slices of marble, you got 15 of red velvet, and you got 20 of chocolate. And it says each row has an equal number of servings, but only one type of cake. So what's the greatest number of servings in each row? So what we have here is we've got a greatest common factor sort of problem. So we need to find the greatest common factor of 10, 15, and 20. Now, many of you just looking at those 3 numbers, if you have a really good number sense, you might be able to know what the greatest common factor is without even doing a whole lot of work. But remember, we're talking about greatest common factor and not least common multiple. So first of all, you list all the factors of 10. And if you remember from the last video, they come in pairs, right? 1 times 10 is 10. 2 times 5 is 10. 3 and 4 do not go into 10, so they are not factors. The factors of 15, we know that 1 times 15 is 15 and 3 times 5 is 15. And that's it. There's no other ones. There's no other pairs. Then you have the factors of 20. 1 times 20 is 20. 2 times 5 is 20. 1 times 20 is 20. 2 times 10 is 20. And 4 times 5 is 20. I was a little confused by all the red and the blinking going on. So if you look now, they kind of cheated and they put all of what we call the common factors. Remember what we said on that last worksheet, what it means to be in common, right? You know, if something is in common, it means it's shared or the same as. And so if you look, all 3 of these, 10, 15, and 20, have 1 in common and they have 5 in common. Well, then we know what the common factors are. They are 1 and 5. So what's the greatest common factor? And greatest obviously means largest. Therefore, our greatest common factor is going to be 5. So the greatest number of pieces in each row would be 5. So you can do the same thing with this one. There's only 2 examples. There's 60 and 42. So what we do is goofed up on me. If we wanted to find the greatest common factor of 60 and 42, we would write all the factors of 60, right? We know that 1 times 60. We know that 2 times 30. And I apologize for the sloppiness of this because I am trying to write with my mouse. This is not my handwriting. We know that 3 times 20 is 60. Then if you want to figure out how many times 4 goes into 60, it does go into 60, and it goes in 15 times. We know that 5 is going to go into 60, and it's going to go in 12 times, right? And then 6 goes into 60 10 times. There are a lot of factors of 60. So these are all factors of 60. 7 and 8 do not go into 60. And then the other number, I forgot what it was. I believe it was 48. List all the factors of 48. You know that 1 times 48 is 48. You know that 2 times 24 is 48. 3 actually does go into 48. 3 times, sorry about that, 16 is 48. That is an awful 3. We'll rewrite that a little bit. 4 goes into 48 12 times, so that's 4 times 12. 5 does not go into 48. 6 does go into 48 because we know that 6 times 8 is 48. So if you look, there are a lot of factors of 60 over here. There's a lot of factors of 48 over here. So what do they have in common? They both have a 1. They both have the 2. They both have the 3. They both have the 4. They both have the 6. Look over here. Do they both have an 8? They don't. They do not have an 8. This one's got 8. This one doesn't. They both have a 12. They do not have a 16 in common. They don't have a 24 or a 48. So our common factors would be 1, 2, 3, 4, 6, 12. And the greatest would be 12. So that's how you find your greatest common factor. Again, sorry for the handwriting. Working through the kinks here. All right. So if we move on to another example. Greatest common factor of 12 and 18. Do the exact same thing, guys. Greatest common factor of 12 and 18. To list the factors of 12, you would do 1 times 12. 2 times 6. 3 times 4, and there's no numbers in between 3 and 4, at least no whole numbers. So those are all your factors of 12, and do the same thing for 18. 1 times 18. 2 times 9. 3 times 6, and we know that 4 and 5 do not go into 18, therefore those are all the factors of 18. So if you look at the ones they have in common, they have the 1, they have the 1, they have the 2, they have the 3, and they have the 6 in common. All right? Therefore, the greatest common factor would be 6. All right, so greatest common factor, it can be a tricky one because you got to have some number sense, and you've got to be able to solve, be able to list the factors and know what the factors are. But this is the problem that, and if you want, we can take a look at a video. And this is all, you can access much of this on the website as well. All right, moving on to least common multiple. All right, so least common multiple, let's take a look at what the video says here. Least common multiple of 2 and 3, okay, using a number line. Guys, finding common multiples is actually quite easy because all we're going to do is list the multiples of each, okay? Now, they're going to use a number line, which I don't think you really need to list, to put X's above all the numbers, but you can see what they're doing is they're showing that the multiples of 2 are 2 and 4 and 6. So they're putting red X's. And then they're showing the multiples of 3 with blue X's, which is 3, 6, 9, 12. And so basically, if you want to find the least common multiple, you look at the lowest number. Remember, look for least, the lowest number that has both X's. So in this case, it would be 6. All right, 6 is the least common multiple. Now, if you use a list, this is the way that I would probably do it, probably the simplest way. Just list the multiples of 2, list the multiples of 3, find the lowest one that they have in common, which here obviously is 6. And those lists could go on forever and ever and ever. Remember that, because multiples are infinite. All right. So moving on to another example, find the least common multiple of 14 and 21 using prime factorization. Now this is a little trickier using prime factorization. It's easier to use prime factorization for bigger problems like this. So what you're going to do in this, you're going to have to go back to elementary school and think about making factor trees and finding the prime factorization of numbers. It's not super duper hard, but the first thing you have to do is you have to find the prime factorization of each number. If you forgot what that means, it's making these little factor trees, right? So we know that 14 is equal to 7 times 2. We know that 21 is equal to 7 times 3. Therefore, basically, you multiply using each common prime factor only once, which in this case, they only have one prime factor in common, which is 7. And so your least common multiple would be 7 times 2 times 3 is 42. So you are multiplying the common multiple once, and then you're going to multiply by each of these other ones as well. I probably didn't say that right the first time, but you're multiplying the common multiple times all of the remaining ones, but you're only going to use the common multiple once. All right. So I'm going to show you another quick example. It says, find the least common multiple of 4, 6, and 8. Now, you could use the prime factorization, but what I would likely do for this one, 4, 6, and 8, is I would just list the multiples because those are just small numbers. So let's list the multiples of 4. 4, 8, 12, 16, 20, 24. And we could go on and on if we need to, but let's just list the first few multiples of 6. 6, 12, 18, 24, 30. And then if we list the multiples of 8, you got 8, 16, 24. And I'm going to stop right there because I can already see that we have a common multiple. So like these two have 12 in common, but there is no 12 here. So you got to find the lowest one that they all have in common, and that is a very awful looking 4, but I am sorry. Again, I'm using a mouse. 24, 24, 24. That is the first and lowest multiple they have in common. So the least common multiple of 4, 6, and 8 is going to be 24. Now I'm going to show you an answer that many kids will give me when I say, what is the least common multiple of 4, 6, and 8? There's a ton of kids that are going to put this. That is actually the greatest common factor of 4, 6, and 8, not the least common multiple. So make sure you know the difference between those two. Can be super duper tricky. All right. So another example of this, a real world example using least common multiple. It says Ernesto has painting class every 2 weeks. Kamala has pottery classes every 5 weeks. So every 2 weeks and every 5 weeks, Ernesto and Kamala met at an art building for class this week. How many weeks will it be till they see each other again? So they're meeting at this building, and Ernesto is going to be back every 2 weeks. Kamala will be back every 5 weeks. So if you take a look at this, the multiples of 2 are going to be 2, 4, 6, 8, 10, 12, 14. The multiples of 5, are going to be 5, 10, 15, 20, 25. So what is the lowest number that they have in common? If you'll notice, the least common multiple here is going to be 10. So they're not going to meet for another 10 weeks. All right. So again, please remember least common multiple and greatest common factor. And remember that the least common multiple, even though it has the word least in it, it's going to be bigger than the greatest common factor. There are times, if I gave you these two numbers, for instance, if I gave you the number 6 and 12, and I said, what is the greatest common factor, meaning the biggest number that goes into it, it is possible that the greatest common factor could be one of the actual numbers itself. In this case, the factors of 6 are 1, 2, 3, and 6. The factors of 12 are 1, 2, 3, 4, 6, and 12. The greatest common factor of 6 and 12 is actually 6. So it's possible that you could have a greatest common factor that it matches one of these numbers. And here's the other part. If I said, what's the least common multiple of these, of 6 and 12? Well, if I listed the multiples of 6, it would go 6, 12, 18, 24. If I listed the multiples of 12, it would go 12, 24, so on and so forth. The least common multiple that they have is actually going to be 12. So it's possible that the greatest common factor could be one of the two numbers if this number goes into the other, and likewise with the least common multiple. So just keep that in mind, a couple of things to be aware of. So, again, I apologize for the sloppiness. We're still working out the kinks here. I'm sure I'll figure out some better ways, or I'll just get better at it. But hopefully this helps. I will be assigning a few basic problems for factors and multiples on Google Classroom here pretty quick.